7.2. Ellipses and circles. This will be fun. So, what we have here. This left column right here is, so an ellipse would look like this, except hopefully better drawn. Sorry, I'm drawn on my device here. But the left column is for when it's wider than it is long. As you can see, it's wider than it is long. And this right column is for when it's longer than it is wide. And those blue dots are our foci. Remember foci from section 1? Yeah, you do. So our blue dots are our foci. So here's standard form. When it's wider than it's long, longer than it's wide. Does it matter? Yes, because A is always bigger. Okay, A is always bigger. Okay. So whatever denominator has the A value, that this case, X is the numerator where A is the denominator, and it's wider than it is long, right? And then over here, longer than is wide, and our A is bigger in this case. We're going to refer to something called the major axis, okay? It's horizontal when it's wider than it is long. It's vertical when it's longer than it is wide. Major axis will come into play many times through different problems. We have a center at h, k. HK, very similar to our parabola. I'm going to skip down the vertices. Vertices, when it's wider than it is long, we're going to add and subtract the A value to our H value. And when it's longer than it's wide, we're add and subtract that A value to our K value. And then foci, key point at the foci, we're going to add C, and I'll talk about C a little later, and how we can solve for C. C is going to be added to, if it's wider than it is long, it will be added to the H value. If it's longer than it is wide, it will be added to the K value. And covertices are the smaller of the two. So it would be the B value that we're adding to what we didn't add to the vertice. Major axis in this case, y equals k, x equals h. Swap them for when it's longer than it's wide. And in order to find c for our foci, c squared is equal to a squared minus b squared. Okay. That's a formula you need to know for finding the foci. Sometimes I'll give you the foci in the vertices and you need to find the b value. I could, and as long as I give you 2 of the 3, you should be able to find the other. We have a couple examples here. So we have a center. We're going to do one on the left first. So we have a center at what? 6, negative 3. So let's graph that. That's a great line. Let's do that again. 6, negative 3. We're in that area. Okay. So now this is going to be longer than it is wide. I know. But in this case, we have the bigger value under y squared. So our A value is what? It's 4. So I'm going to go up 4 from here, which is going to be a little above the line at 1, and then down below here. And then we're going to go over 3 because our B value is 3. 3. And we'll look something like that. Also label the points, please, whenever you're doing this. So we have 6, 1, 6, negative 7, 9, negative 3, and finally 3, negative 3. And now the other one. So this one over here looks scary, and I don't want you to be scared. I'm sorry if you're scared, but you shouldn't be, okay? Because we're going to take care of you, okay? I'm going to put the x's together and the y's together, and then I'm going to leave a space there. And I'm going to subtract the 103 to the other side. Now we got to do something, if you remember, called complete the square. So divide that value by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to both sides. going to give me negative 99 over here. Now I can't do that to the y until I factor out the 4. I'm going to go ahead and factor the x, so it's going to be x plus 2 squared. If you factor and it's not something squared, you did something wrong completing the square. So I'm going to factor out a fourth y, so we get 4 parentheses y squared minus 10y, and divide negative 10 by 2 and square. We're going to add 25, and I'm going to add 100 to the other side. Now where did my 100 come from? 25 times 4. If I added something here and I factor out a number, you have to multiply and add it to the other side. So it's 100 over here. So we got 1 equals, I'm going to factor down, we're going to get y minus 5 squared for x plus 2 squared. Now this one's a little bit ugly. So anytime, I'm going to have usually a number on this right side we're going to divide by, and we're going to get values in the denominator, but in this case that's not going to happen. So what I'm going to do instead, x plus 2 squared, since I have 1 on the other side, divided by 1 is going to be itself, but I'm going to write it as over 1 to help me out when graphing. Anytime we have a number left over on the numerator, put it in the denominator and flip it. And that's what it's going to look like. I'm not going to graph that. It's going to be a very small ellipse when you do graph it. But I will not be giving you any on assessments with a fraction bottom like so. At least not once a fraction smaller than 1. So in these problems, I'm going to give you some information, and you are going to tell me what the equation of ellipse is. Now, there's some things I should further explain so you understand where numbers are coming from. So let's say this blue dot right here is our center, foci of the red dots. Okay. So our C value is the distance from our center to our foci. So that's C right there. A is the distance from our center to, since it's wider than it's long, that's A. That's A. Okay? And B would be what's up and down in this case because it's wider than it is long. Now, that's important. So if I'm giving you these two foci and a major axis length equal to 30. So if our major axis is equal to 30, and if you look here, there's two A's, right, that make up our major axis. So if I just divide this by 2, I'm going to get my A value. So A is equal to 15. Now, what is C equal to? Well, C, if I'm giving you the two foci, the halfway point's my center. Okay? Halfway between 19 and negative 7 is going to get me 6. So center at 6, 3. Distance from the center to one of the foci is 13. So your C value is 13. Okay? So if I know my center, x minus 6 squared, and my denominator would be the a squared, so it's going to be 225. Make sure it's 225, not 15. It's a common mistake. Plus y minus 3 squared is 1. Now to find what b is, how am I going to do that? Well, let's go back to memory lane here. C squared equals a squared minus b squared. Would you look at that? C squared equals a squared minus b squared. And I know c squared is going to be 169. I know a squared is going to be 225 minus b squared. Algebraically, it's going to end up being b squared is equal to 56. So I'll put 56 down here and we got our answer. How about that? Next, what do we have here? So we have a minor axis length of 10. So minor axis is equal to 2 b's. Okay? So if I know the minor axis length is 10, that means I know my b is equal to 5. And now if vertices at these points halfway in between them will give me a center of negative 2, 2, giving me an a equal to 6. Now what's changing here? The y. So since the y is changing with our vertices, the y squared is going to get our 6. So y minus 2 squared over 36 equals 1. X plus 2 squared over 5 squared, 25. There we go. Eccentricity is something we're going to briefly mention. It's the ratio of C to A. And the value will always be in between 0 and 1. If you have an answer that's not between 0 and 1, you're wrong. And it will determine how circular or stretched the ellipse will be. The closer you are to 0, the more circular it is. The closer you are to 1, the more thinner it gets. It's going to be more like that. The equation for that's E equals C over A. So let's determine the eccentricity of the ellipse with the given equation. So A is going to be equal to square root of 48. And if you remember, A squared minus B squared is equal to C squared. So C squared is going to be equal to 48 minus 18, which is 30. Square root. So what you're going to have to do is going to be the square root of 30 divided by the square root of 48. You put that in, you're going to get 0.79. So that's going to be fairly stretched out, okay? It'll be long ways since, as you can see, the A value is under the Y squared, but nonetheless, it is still going to be pretty stretched out, more stretched out than more circular. Speaking of circle, standard equation for a circle with a center at h, k and a radius of r is as follows. Very similar to your ellipse, except nothing to the denominator, okay? Because we care more about what the radius is. Last thing we have write each equation in standard form and identify the related conic. So let's look over here to the left. First example, we have 4x squared plus 3y squared. What does that look like to you? That looks like that's going to be, when these numbers are different right here, it's going to be ellipse. They're when the same circle, in this case, an ellipse. So we're going to identify as ellipse, and we're going to write the equation standard form once again. Completing the square. So factor out of 3, so it's going to get us y squared plus 12y, and move the 60 over. And then what am I going to add here? 12 divided by 2 is 6. 6 squared is 36. And what am I going to add to both sides? It's going to be 108. It's going to give me 48 over here. And then I'm going to factor, give me y plus 6 squared, 3 there, 4x squared, divided by 48. Give me x squared over 12 plus y plus 6 squared over 16 equals 1. Last one, I see a y squared, I don't see an x squared, so that means we have a parabola. That's easy enough, right? You see only one value squared, we got parabola. So I'm going to move the x's over and the constant to the other side to help me out. Y squared plus 6y blank 3y, it's 3x rather, excuse me, minus 12 because I moved the other to the other side. 6 divided by 2 squared is 9. Now if I add 9 on one side, I need to add to the other side. So it be y plus 3 squared equals 3x minus 3. Factor out of 3. And here's your equation for your parabola. I appreciate you, and you have a lovely rest of your day.